Here you'll learn about common laser hazards in the laboratory and ways to minimize the potential for overexposure. An open beam is one that is not totally enclosed. Open beams may be accessed during alignment procedures. There are many other conditions where open beams may occur, but of particular concern is when errant beams are directed into uncontrolled areas. Use low-powered lasers with visible emissions. Use cards for the safe viewing of diffuse reflections from low-powered Class 3B lasers. Use sensor cards that fluoresce or re-radiate energy at a different wavelength from the originating beam. This allows you to safely view the beam through protective eyewear. Use an infrared imaging scope to safely view the diffuse reflection of the beam through protective eyewear. When setting up an experiment on an optical bench, do not allow the laser beam to be directed into any area where people are located. While conducting experiments, you may need to transmit beams into areas that were not previously defined as laser-controlled areas. Before energizing your laser system, be sure to implement basic controls. To protect people entering the lab, place interlocks on the door to the lab or place curtains or coverings over the doorway while the laser is in operation. Post a danger sign outside the door to the lab. To decrease the risk of exposure to people inside the lab, use temporary barriers. Beam stops that absorb the beam and that are fire retardant prevent beams from leaving the benchtop. A single laser can generate multiple wavelengths, some visible, others invisible. In addition, when a laser is used as the pump for another laser, there may also be more than one wavelength. A potentially hazardous error is to select eyewear that is suitable for only one of the wavelengths. Read the label on your protective eyewear carefully and be sure you understand which lasers it offers protection for. Be sure to select eyewear that protects you from all wavelengths produced by your laser. Do not select eyewear based solely on the color of the filter. The eyewear should be marked for your particular application. Optical systems such as mirrors, microscopes, lenses, and hand magnifiers can cause specular and diffuse reflections. They can also collect and concentrate the beam, increasing its potential hazard. If the microscope does not contain a permanent filter for the laser wavelength, one should be installed before use. If you can't do this, use protective eyewear. Crowded conditions expose more people to greater risk, and poor housekeeping can create an infinite variety of hazards. For example, a misplaced tool or glass beaker can cause a specular reflection, or a simple reflex action in crowded quarters, such as reaching for a falling object, can move you into the path of a beam. Keep your area as neat as possible. Put away all tools and materials when you're done using them. If two or more independent activities are being conducted in a lab, place a barrier between each optical table. Whenever you remove the protective housing of an optically pumped laser, you risk potential exposure to collateral radiation, as well as the beam. Leakage of light from the optical cavity may expose you to high levels of visible and ultraviolet radiation. Wear personal protective equipment, including eyewear that protects you from ultraviolet radiation. When using chemical agents such as compressed gases, dyes, and solvents, you may be exposed to airborne contaminants and potential skin hazards. A good local exhaust ventilation system, such as an exhausted gas cabinet or a laboratory fume hood, will help reduce the potential for exposure to airborne contaminants. To help minimize exposure to chemical agents, you may need to wear personal protective equipment such as gloves and eyewear.